Hey everyone, welcome back to another video by Camroom 5. In today's video, we are going to be performing qualitative analysis on various salts, and we're going to see the observation and their equations. I have salts of iron 2, iron 3, copper 2, chromium 3, aluminium, and zinc. In order to identify, I have aqueous ammonia, which is an alkaline solution, and sodium hydroxide, which is again an alkaline solution containing OH minus ions. The samples are given to us generally in a boiling tube, which is a glass tube containing the sample and for heating. We perform the test in a test tube which is a little more thinner than the boiling tube. Test tubes don't have any graduation on them, but in test tube we carry 1 centimeter cube depth of sample. The reason is that we don't want to waste chemicals, and it's better to perform smaller testing on small samples. If the solutions are colored, it means they contain transition metal compound like copper 2, iron 3, chromium 3. If they are colorless, general assumption is they do not contain transition metal compound. Whenever we want to perform a test, we first take the sample in a clear test tube, which is dry obviously, and we carry almost 1 centimeter cube depth of the sample, which is a small amount, and we don't want to waste chemicals. The first test is mostly adding aqueous sodium hydroxide drop by drop until a change is seen. So you trickle the sodium hydroxide sample through the walls of the test tube. If it's iron 2 ions, you will see green precipitates which are going to be insoluble in excess. The reason is that iron 2 ions react with hydroxide ions to make iron 2 hydroxide. This is a precipitation reaction. If you continue to add excess sodium hydroxide in the same test tube, iron 2 ions will give you insoluble green precipitates, as you can see. These green precipitates are insoluble in excess no matter how much sodium hydroxide you add. So this is the test for iron 2. Let's perform the same test with aqueous ammonia, and let's see what happens. Now if you take another test tube, which is clean dry test tube, and you add some amount of iron 2 sulfate. Iron 2 sulfate was a solution, but imagine you didn't know that it's iron 2 sulfate. So you take a sample in a clear dry test tube. Now you're going to add aqueous ammonia now, which is the second test performed on the same sample. You add drop by drop, and you see that the same kind of green precipitates are made when you added drop by drop aqueous ammonia. If you continue to add aqueous ammonia in excess, you will see that green precipitates formed are insoluble in excess. This shows us that iron 2 ions were present. And what is the identity of those green precipitates, by the way? This is actually iron 2 hydroxide made, because ammonia was also an alkaline solution. Now let's move on and let's take another salt sample. This is a kind of a yellow solution which already hints us that the iron 3 ions are here. Iron 2 is green in color and iron 3 is yellow in color, especially if it's iron 3 sulfate. You can see the color difference, which is not very prominent but enough for us to know. Now let's take a clean dry test tube and take a small amount of sample of this salt. I'm going to add aqueous sodium hydroxide drop by drop in the sample. You will be able to see that red-brown precipitates are made. You can clearly see that these are the red-brown precipitates made when a small amount of aqueous sodium hydroxide was added. These precipitates are none other than the iron 3 hydroxide made by the precipitation reaction. If you add excess, the red-brown precipitates will remain insoluble in excess. So iron 3 ions give red-brown precipitates which are insoluble in excess. Let's move on and let's perform the same kind of testing using aqueous ammonia this time. I'm going to take a sample in a clear dry test tube. I'm going to add drop by drop of aqueous ammonia in the sample until a change is seen. Iron 3 ions will again give me red-brown precipitates which are going to be made as soon as the aqueous ammonia is added. You can see that these red-brown precipitates are here and they are obviously insoluble if I add excess aqueous ammonia. The reason is that the iron 3 hydroxide made here will not dissolve in aqueous ammonia or aqueous sodium hydroxide. This is the test for iron 3 ions. Now let's move on and let's take this new sample which is, I know, chromium 3 ions, but let's suppose we didn't know this. It's a slightly green solution, green-blue, or you can say sea green solution. When you see the color, you'd know that this is definitely not iron 2 green. It's a different green. When you add aqueous sodium hydroxide, drop by drop until a change is seen, you will see that precipitates are made, and these precipitates are gray-green in color. They are green definitely, but they are not iron 2 green, so they give you green precipitates which are definitely a little different than the iron 2 color. The reason is that chromium ions react with hydroxide ions and they make chromium 3 hydroxide. But something new happens here, that when you add excess, the precipitates dissolve. The green precipitate of iron 2 never dissolved, but in case of chromium 3, they do dissolve. Now let's perform the similar kind of testing on this sample using aqueous ammonia. When I add aqueous ammonia drop by drop, I will see that again some green precipitates are made. But read it, it says insoluble in excess, so in case of ammonia, these kind of gray-green precipitates will remain insoluble no matter how much aqueous ammonia I add. So this is one distinguishing feature. With sodium hydroxide, they gave me clear green solution, but with aqueous ammonia, the precipitates remain insoluble. Now let's move on to the most anticipated salt, which is very obvious that it's copper 2 solution. Copper 2 solution has this characteristic blue color, and you obviously know that this is a copper salt. When I add aqueous sodium hydroxide drop by drop until a change is seen, I will see pale blue or blue precipitates. But if you read, it clearly says insoluble in excess. So the copper 2 ions react with hydroxide ions to make copper 2 hydroxide. But if I add excess sodium hydroxide, the precipitates do not dissolve. So precipitates are insoluble in excess. This is first of the tests for copper 2 ions. Let's perform a similar kind of testing, this time with aqueous ammonia. When I take copper 2 sulfate, a small amount of sample in a clear dry test tube, and I add aqueous ammonia drop by drop until a change is seen, I will be able to see this time very clearly pale blue precipitates, as you can see in this video. These pale blue precipitates are made because actually copper 2 ions made their copper 2 hydroxide. Now what happens if I add excess? Because it says soluble in excess giving dark blue solution. You can see that I add excess aqueous ammonia, I can clearly see precipitates have dissolved and a dark blue solution is made. This is another characteristic feature of copper 2 ions testing. Now since we are done with the colored solutions, let's go for the colorless ones, aluminium and zinc notably. When I take a sample of aluminium ions, I can add drop by drop aqueous sodium hydroxide and I will see white precipitates. These white precipitates are made because aluminium ions reacted with hydroxide ions from the sodium hydroxide and they made aluminium hydroxide. If I add excess aqueous sodium hydroxide, the precipitates dissolve. This is the test for aluminium ions, white precipitates soluble in excess sodium hydroxide. Now I will perform a similar testing using aqueous ammonia on the aluminium sample. It says aluminium ions give white precipitates insoluble in aqueous ammonia. So when I add excess aqueous ammonia in those white precipitates, they will not dissolve. So this is another distinguishing feature. White precipitates of aluminium hydroxide do not dissolve in aqueous ammonia, but they were clearly dissolving in sodium hydroxide. The last test is going to be on zinc sample. When I take a sample of zinc salt and I add aqueous sodium hydroxide, I see again sodium hydroxide gave me white precipitates. And these white precipitates look very similar to the white precipitates of aluminium, because zinc hydroxide and aluminium hydroxide gave me similar kind of white precipitates. And as I add excess sodium hydroxide, these precipitates are also kind of dissolving. They take a little time, but they do dissolve, giving me a clear solution. So in this way, testing between aluminium and zinc becomes very difficult, because they both gave white precipitates and both white precipitates were soluble in excess sodium hydroxide. But don't worry about it, because aqueous ammonia is going to help us. When I add aqueous ammonia, it gave me white precipitates. But this time, the white precipitates will dissolve in excess aqueous ammonia. So the white precipitates of aluminium hydroxide were not dissolving in aqueous ammonia, but white precipitates of zinc hydroxide will definitely dissolve in aqueous ammonia. This is how we distinguish between the samples of aluminium and zinc using aqueous ammonia solution. You will have to shake it vigorously like I am doing right now, but at the end of the day they will dissolve. This is how you distinguish between zinc ions and aluminium ions. I hope these videos are clear to you, and it will definitely help you in performing your ATP paper. Stay tuned, guys.